Hey guys, Mrs. O'Donnell here. Today we're going to start factoring. We're going to continue using the box method. So we've already talked a little bit about this in some of the other videos, but now we're going to really dive into it. All right, so today the goal is to develop procedural fluency factoring our polynomials. I have posted quite a few of the videos. Just keep in mind, if you need to come to office hours, you can come to office hours for some extra help. All right, so our warm up here, and you can take a minute and pause and see how you do, but fill in the boxes with whatever needs to be there to make the equation true. You can use numbers and letters. Okay, so give yourself a little challenge. Then down below it says, with a shortcut, convert from factored form to standard form or vice versa. Okay, so pause the video, give this a try. All right, so let's see here. If I'm going to work through this, I know 2x times 5x is going to make that 10x to the fourth. So 2 times 5 makes the 10. X to the first power times x to the third power would make that x to the fourth power. So I know a 3 is going to have to go there. And then let's see here, I've got a 3, and I have to think, what is it going to multiply to make 6x squared? So I know I'm going to have an x squared, probably a 2x squared. Would be how I would fill in those boxes. And then we could go ahead and test it out, right? So we know our first terms multiply to make that 10x to the fourth, and then our last terms multiply to make that 6x squared. So we really just need to test out sort of the middle terms to see if they make that 19x cubed. So that would be if I multiplied 2x times that 2x squared. So 2x times 2x squared leaves me with 4x cubed, and then 3 times 5x cubed, 3 times 5x cubed, which gives me 15x cubed. And if I add 4x cubed and 15x cubed together, I get my 19x cubed. So I know that that middle term works out. So it worked. Okay. With a shortcut, convert from factored form to standard form or vice versa, right? So here I see my two perfect squares, which means I'm going to square my first term, 2 times 4 times x, and square my last term, so 4 squared. So that means I have x squared plus 8x plus 16. That would be that shortcut. Okay. Let's see here. Down below, I don't think I have a shortcut, right? Because it's not a difference. Or it's not going to give me a difference of two perfect squares because I have a 3 and a 5. So I don't really have a great shortcut here. I could just kind of hop over to the side, make my area model, and multiply it out. So I've got x minus 3, x plus 5. That gives me x squared, negative 3x, 5x, and negative 15. So this gives me excuse me, x squared, negative 3x plus 5x is 2x minus 15. All right, so write a shortcut, convert from factored form to standard form or vice versa. So this is the part where it starts to get tricky, right? So I'm not going to, for time's sake, I'm not going to dive into this because we're about to learn factoring, but this would be a really good challenge. See if you could do some reverse engineering to go from that box, from the inside of the box to sort of that outside of your box. All right, so for our introduction to factoring, we're going to figure out what needs to go into our blanks, right? And this is what I really love about factoring, is that it really challenges your number sense because you have to do sort of this backwards thinking, right? So with our traditional area model, what we're doing is we're multiplying, right, the outside edges of our box or our rectangle or whatever you want to call it, our area model, to get what's inside, the area inside. Well, so now we're going to kind of think backwards. So what two numbers or letters multiply to make x squared? Well, I know x and x. Same thing, what two numbers, or x times what, is going to multiply to make 5x? Well, that has to be a 5, right? 5 times x is 5x. And then same thing down here. I need to think what number, x times what number, is going to multiply to make 2x? Well, that's going to have to be a 2, right? And I could follow through and double check. Okay, 5 times 2, does that make 10? It absolutely did. Okay, so I ended up with x plus 2 times x plus 5. That's my factored form of this polynomial. All right, so if we go ahead and hop into the next one, well, so that first problem, they gave us our area model sort of all filled in. In this problem, they're just telling us our polynomial, x squared plus 10x plus 21, and we have to do some figuring out of what's going to go inside of our area model, right? So I know I've got x squared, I know I've got a 21, and I know that my diagonal here is going to add to make 10x, but I don't exactly know how that's going to split apart yet, right? I could add to make 10x a lot of different ways. So let's see here. So if I start working this out, I know x squared is going to be x times x. So I want to think, what kind of numbers multiply to make 21? And then I'm going to look for those numbers that add to make that 10x, right? So I'm looking for numbers that multiply to make 21 and add to make 10x, right? So my numbers that multiply to make 21, I've got 1 and 21. 21's not even, so it doesn't divide by 2. I've got 3 and 7, and I think that's really it. So those are really all of my factor pairs of 21. And then I want to think, okay, which numbers there are going to add to make 10x? Well, if I add 1 and 21, I get 22. If I add 3 and 7, well, here, I got 10. So let's see here. If I have a 3 and a 7, right? 3 times x, that's going to give me 3x. And 7 times x, that's going to give me 7x. If I add those together, I got my 10x that I was looking for. I know my 7 times my 3 made that 21. And voila, my final answer for my factored form. Oh, I have to sneeze, excuse me. Sorry. Oh my gosh, I'm so sorry. Okay, so, excuse me. My final form here would be x plus 7 times x plus 3. That's my factored form. If we wanted to solve to find our zeros, right, that means that we would be setting it equal to 0. So x equals -7 and x equals -3. When you set it equal to 0, you're using that 0 product property to figure out what number, when you plug it in, would make each of your products equal to 0, or each of your factors equal to 0. Whew. All right, so let's look at another one. All right, so we've got x squared minus 2x minus 3. We know we've got an x squared here. We've got a -3 here, and we know our diagonal is going to add to make -2x, right? So we want to start thinking, okay, I know x times x makes x squared. I know I'm going to look for my factor pairs that make -3. So I've got -1 times +3 or +1 times -3. Those are really my only options. And I want to find factor pairs that add to make -2x, right? So if I do -1x plus 3x, I get +2x. If I have 1x plus -3x, I get -2x, and it looks like that's the one that worked. So I want to have a +1 and a -3, and let's just double check that. So x times 1 gives me 1x, x times -3 gives me -3x, and when I add those together, I get that -2x. So there are my factor pairs, right? So I've got x minus 3 times x plus 1. If I want to solve to find my zeros, I'm really just taking that and setting it equal to 0. So I know I've got x minus 3 equals 0, which means that x equals 3, and x plus 1 equals 0, which means x equals negative 1. And those are my zeros, or my roots. And that's really all I've got for you today for the first part of factoring, where you have a is equal to 1. So go ahead and hop on to your Google form and give that a try. Thanks so much, and I'll see you tomorrow.